I got a question over email about the algebraic way to solve monopoly problems. And remember, monopoly problems, just graphically, we had the situation where a producer faces this demand curve. Often we assume a linear demand curve just for simplicity. Marginal revenue is a downward sloping line that shares the y-intercept is twice as steep. There's a marginal cost function. The profit maximizing quantity, this should be all reviews, so I'm moving fast, is where marginal revenue and marginal cost are just equal. That gives us a profit maximizing monopoly quantity, and the associated price we get off the demand curve. Well, the question was, how do I do that in the algebraic form? And in the general form, remember that in an algebraic system, we get our demand curve in algebraic terms. So we have the equation for a line instead of the graphical form, and we have P equals m times Q plus B, where m is the slope, always a negative number because of the law of demand, and B is the y, or the price axis intercept. All right, and then remember the general rule: if we have a linear demand curve like that and it's a monopoly problem, marginal revenue function is just that, is a line that's twice as steep, so its slope is 2m, and then it has the same y-intercept. And then there'd be some marginal cost function, or it might just be a constant marginal cost level, and our output rule is marginal cost, produce output where marginal cost and marginal revenue are the same. So that's just an overview of how you do it in the most general case. And I wanted to give you an example, just pulling a demand curve and a marginal cost function out of my head here. So I'm going to get a new page here. Let's suppose we had a demand curve P equals 10 minus Q. Very easy function to work with. Let's say also that we had a marginal cost function. It's supposed to be a semicolon there. Marginal cost function, 1 plus Q. So it's an upward sloping marginal cost. As we produce more output, marginal costs are increasing. That's consistent with our notion of how the short run works in the general case. All right, well, what do we do? Well, remember that marginal revenue is equal to same y-intercept, that was 10, minus 2q. We just double that slope of -1. Now it's a slope of -2. And then our output rule is produce where marginal cost and marginal revenue are equal. And so we can just plug these relationships. Marginal cost is 1 plus q. Marginal revenue is 10 minus 2q. 1 plus q equals 10 minus 2q. I'm going to add 2q to both sides. I'm going to subtract 1 from both sides, and this becomes 3q equals 9, and of course that means q is equal to 3. Now when I want to know what the associated market price is, I'm going to plug that 3 into the demand function. So P equals 10 minus Q. 10 minus 3 is 7. That's supposed to be an equal sign. All right, so quantity is 3, price is 7, and that's done. We might want to know how much consumer surplus is. It's always the area below the demand curve above the price. You know, producer surplus, the difference between price and marginal cost summed up overall output. So it's the area below the price and above the marginal cost curve. We've done that numerous times, and we might be called on to do that again. But this is the basic algebraic solution. I guess, you know what, let's do the whole problem. If you get an algebraic solution or an algebraic problem, then you're asked about consumer surplus, I would recommend mapping it out. So let's just do that same algebraic problem, but now just translate it into graphical form. So the way we draw that demand curve, P equals 10 minus Q, so got a vertical intercept of 10, actually a horizontal intercept of 10 as well. The marginal cost starts at 1 and then is upward sloping. And that's our marginal cost function. The marginal revenue function is twice as steep. Just going to cut the x-axis at 5. I didn't quite draw that. One good way to do it is just to bisect. You know that this line that's twice as steep is going to cut the x-axis at the midpoint between 0 and the quantity axis intercept. Anyway, we solve this algebraically. We know that quantity is 3. We plug that into the demand curve. We know that price is 7. And we can actually do consumer surplus. That's this area below the demand curve above the price. That's a triangle that's a 3 by 3 triangle. 1/2 times 3 times 3 is 4.5. Producer surplus, a little bit harder, but not that hard. This is going to be 4. It's not quite drawn to scale, remember, because it's 1 plus Q. Marginal cost is 1 plus Q. Producer surplus is this little sort of backwards Nevada shape. So that's the area of this rectangle, which is a 3 by 3 rectangle, base times height. And then it's this little triangle here, a 1 by 3 triangle. That's 1/2 times 1 times 3, and lo and behold, producer surplus is 10.5. All right, just a little bonus there.